So for question number 2 on the 2014 AP Calculus AB for response, we have our first calculator question. Well, not the first one, but of my videos. So anyway, we have a region R that's enclosed by the graph of f of x equals x to the power of 4 minus 2.3 x cubed plus 4, and the horizontal line y equals 4, which is basically what they told us. So let's go ahead and read part A. Find the volume of the solid generated when R is rotated about the horizontal line y equals -2. So let's make a line y equals -2 right about over here. And if I can get it straight, there we go. Let's call this y equals -2. Now, before we do anything, let's find what these points are, because I can tell that we're going to need to find what these points are. And by doing this, we need our graphing calculators. Actually, it's funny because in this question, we actually don't need our graphing calculator to find the zeros. And you'll see why in just a minute. But basically, we get this by setting the graph equal to the horizontal line y equals 4. And what you notice is when you subtract them to equal to 0, the 4 is canceled. And you're just left with x to the power of 4 minus 2.3 x cubed equals 0. You can factor out an x cubed, you're left with x minus 2.3, x equal to 0.3, and 0. But let's go ahead and graph this anyway, for those of you that aren't comfortable with factoring or anything. So let's do this for part A. Instead of part A, let's write part A right here. Let's write it up here though. X to the power of 4 minus 2.3 x cubed plus 4 is equal to 4. Subtracting 4, we're setting them equal to each other because so that we can subtract from one side, set equal to 0, that way we can graph it and find zeros. So 4's disappear, you're left with x to the power of 4 minus 2.3 x cubed is equal to 0. So let's go ahead and graph this on our graphing calculators. Y is equal to x to the power of 4 minus 2.3 x cubed. Graph. Now, the reason why I wanted to graph this is because when I did this problem a few days ago, along with fellow peers of mine, they actually got a zero of, not a zero, they actually got 5.00 times, let's write it out, 5.0023 times 10 to -5. Now, when a calculator gives you a number that's this small or anything, or this close to a certain number, it's understood to be the whole number nearest to it, because this is 0.00005, which is pretty close to 0. So, if you guys wrote this on the AP test, I doubt you would lose points of it because this is the calculator's fault. But however, since you could solve this by hand, I'm not sure. But if we were to do the 0 option right now, second calc 0, we would do the left bound -1, and we would do the right bound about here. Enter, enter. It gives us a 0 of -2.16 times 10 to the -34. Now this is a very, very, very small number. This is -0.00033 times 216, and that's pretty close to 0. So if you got this number too, I don't know, I'm not sure what's going on. It could be the calculator's fault. I actually did not get this number when I tried it. I got, like I said, this. But this is understood to be 0. So we have them equaling 0, and we proved it by factoring out an x. So writing this, we have pi times the integral from 0 to, let's find the second 0, which is, 0, let's start here, and put 3. We have the 0, 2.3. So from 0 to 2.3, and now this is where we have to understand. It's going to be the larger radius minus the smaller radius. Now, since we're rotating around y equals -2, the bigger radius is from the line y equals 4 all the way to -2, and the smaller radius is from the graph f of x to negative 2. So we have the bigger radius, which is 4 minus minus 2 squared, which is 6 squared, minus the smaller radius, which is x to the power 4 minus 2.3x cubed plus 4 minus minus 2, or x to the power 4 minus 2.3 x cubed plus 6 squared dx. Now, evaluating this, we have my calculator responds. We have function integral of 36 minus, let's put parentheses, x to the power 4 minus 2.3 x to the power 3, or cubed. Oops, that's not a 2.3. Let's go back. Minus 2.3 x to the power of 3 plus 6 squared, comma x, comma 0, comma 2.3. There we go. We get the answer of, well, half the answer, 31.4, open it back up, 706. 706. And don't forget the pi. And that is the answer to part A. Part B. Let's write it all the way up here. And let's draw a line to divide the work. Good enough. Oh, no, never mind, not straight. Part B. Region R is the base of a solid. For this solid, each cross-section perpendicular to the x-axis is an isosceles right triangle with a leg in R. Find the volume of the solid. Okay, so if you remember, an isosceles triangle is a triangle with two equal legs and a hypotenuse. So basically a 45, 45, 90 triangle. So here are the legs. Note that one of the legs is also the height of the triangle. So if it tells us that region R is one of the legs, that tells us that the distance of, or the length of one of the legs is 4 minus x to the power 4 minus 2.3x cubed plus 4. So we would have the distance, we would have the legs being, if we were to do this, it would be 4 minus x to the power 4 minus 2.3 x cubed plus 4, and let me go back here and make that a minus. We have 4 minus 4 and the 4's cancel, so I'm just write that right now. We are left with negative x to the 4 plus 2.3 x cubed. That is one of the legs of our triangles, cubed. Now, the area of a triangle is base times height divided by 2. Now, since the base is the leg and the legs are equal, base times height would just be this squared. And don't forget divided by 2. So now this is the formula for the area of our triangle. So now if we integrate this, and remember, it goes from the same place, 0 and 2.3 dx. This should give us the answer to our question. So now let's go back to our calculator. Integral of parentheses, parentheses, negative x to the power of 4 plus 2.3 x to the power of 3, close the first parentheses, square it, close the second parentheses, divided by 2, comma x, comma 0, comma 2.3. We are left with 3.5737. So our answer is 3.5737. And that is the answer to part B. Part C. The vertical line x equals k divides R into two regions with equal areas. Write, but do not solve, an equation involving integral expressions whose solution gives the value k. Now, I believe there are two ways to answer this, if not more. I'll solve it one way because this is the way I prefer it. So basically, it tells us that there's a line x equals k that divides R into two regions. So if I were to get a different color, maybe orange, and cut it in half. I know that's not half, but it doesn't matter. It should tell us that the integral from 0 to k, or from k to 2.3, of 4 minus x to the power 4 minus 2.3 x cubed plus 4 should be equal to the entire integral, 0 to 2.3 of that whole thing, divided by 2. So, writing this out, we have, here it is, the integral from 0 to k of 4 minus that. Now, we already did that right here for the triangle, so I'm just going to write it as that. Or, because this is because the AP graders actually grade in a funny way, we could just leave it as 4 minus f of x. And I'll do it this way to save time and make it look cleaner. Dx, because remember, it's just area. So I didn't even need those parentheses, but I'll leave it, is equal to 1/2 times 1/2 the integral from 0 to 2.3 of 4 minus f of x dx. And just to make sense with our answer, with our other problem, yeah. So this is the answer to part C. And again, there's another answer to it, but I personally prefer this way. So yeah, this concludes question number 2. Hope you guys enjoyed and learned, if you guys didn't know. But yeah, thank you.